Yes, hi, I'm Noah from Tetra Pak, and I've been a data science manager for about a year. We started a data science center of excellence at a kind of corporate level. We have a big company. We have lots of projects across the company. I don't just do predictive maintenance. Although a year before that, I was a consultant from a big data company. I did some of the initial predictive maintenance modelings before there was a data science department. So I've seen a lot of where you can come from like just hiring a consultant to like where we are today. It's been an incredible journey. Before I start, like, is anyone here like how many people here are like hands-on with data? How many of you guys get hands-on with data? Okay, good. Maybe this will be more resonate with you. I think it's really the positioning of like person who is at the mercy of the business to say, we want you to do something with the data. And it's sometimes, this presentation will hopefully empower you to be more kind of tactical with your business to make them make more sense. I also wondered how many people are from the food industry. Anyone? Food industry? Tetra Pak customers? Anyone? Tetra Pak customers? Oh, I'd like to meet you after. Okay, let's get started. So this is our journey in predictive maintenance. Apologize for the slide doing that, but I had a problem with my PDF or I think the PowerPoint didn't work. So we actually started this over 10 years ago with like a technology project looking at sensors. Just, it was a technology, like where could we put sensors? And then, it was about IoT came on and we've been evolving until, it took 10 years before we actually had, a center of excellence for data science to actually start working with data. I mean, that's the journey we decided to empower our like business to roll out sensors to our equipment, which we have thousands of equipment across the globe. And what that now that we have the service, we have this idea of the maintenance mix evolution, where today you might be, we are offering a service where you can get some predictive maintenance, and we try over time to get more predictive maintenance out of you to reduce your corrective downtime and reduce predetermined downtime. This is a journey. This isn't just a magic button that all of a sudden from one day to the next you're going to see all the value. It's a journey, and we hope like that that it's an attractive initial start. I think we already have a business case to start with, and it's only we're working with you in collaboration. We keep building the value. So this is our founder, Ruben Rousing. I just have a quick kind of, the company advertisement. He was, born in the 1800s actually, and in about mid 20th century, he was studying in the U.S. and started to like realize how industries are evolving to mass consumerization, and I guess at his time he had developed this filling machine concept and patented Tetra Pak packaging. And at his time he must have been doing the big data of his time. In 1950s we delivered the first filling machines out of Lund, where we still are headquartered today, and been going ever since. We're still, we make over 500 million packages per day. That's a lot, and we're still a family-owned company run by the founders, the founders' children. It's quite a special place. I've worked many years before in like big energy companies, and I've seen a lot of different kinds of companies. I really think Tetra Pak's a special place. This is I love this image, the idea of like that how everyone here is impacted by Tetra Pak every day, and our commitment to, you don't really notice that you're every day. We go unnoticed 400 million times a day. Now that's 500 million times. It's a few years old. But that makes it fun to be a data scientist. There's a lot of data. There's a lot of people buying our products. There's a lot of hundreds of customers, thousands of machines. There's a lot of excitement out there for where we can go with this. Our vision is the commitment to keep food safe and available everywhere. We're in 180 something countries, and I believe some of the like smaller African countries like have literally developed their country based on the fact that they could deliver food to the population in some kind of Tetra Pak system. So it's a lot of impact around the globe there. This is our figures. This is 2 years old, but I quickly grabbed it from my last presentation. We are over tens of billions in sales. We have 24,000 employees. We make over 188 billion packages per year. for all the customers and all the sites. That's a lot of packages in 170 countries. Down there on the bottom of this is you see our complete solution. Now, what's really kind of obscured there is this little part in the middle, the filling machine. That's the core Tetra Pak founding filling machine concept that still is the continuous filling machine. That was the initial invention, and we now have many types of packages, and that's was the start of the focus of our predictive maintenance solution. But we've now expanded to the left side, all of our processing equipment. And to the right side, we're going to look into distribution equipment. Because if it's not just the filling machine, it's so processing equipment, you have there's a lot of the bottlenecks in that capacity constrained there. And then on downstream, you have one distribution equipment can make the whole line stop. So combination of looking at individual machines and the whole line, where we have quite a nice perspective there. This is an example of our solution. If you have these filling machines, you can pay a small subscription fee per year to have us come and put on the sensors, and they connect to our cloud solution, and we start collecting data and offering predictions and monitoring on these, what we call the functions. And this is just a start, and we're always expanding the portfolio of what we cover. So, but here's the agenda for today. Sorry about that, the slide there. But this first one says how to prioritize, and then what we need to do, and then how to sustain the value. It's better shown here. On the next, I'm going to go into how to prioritize. This is the proof of value process that we, as a data science organization, that it can go throughout the entire company, and where predictive maintenance agenda is one of the areas where we offer our support, is that we want to make sure that we are prioritizing the right things. Because if you don't, you'll just end up sending data scientists in, someone saying, here's some data, make some magic. And I tell you that 90% of the time, that will just end in frustration for everyone. And long times to decide that maybe something's not working. I think the idea of failing fast was an initially good concept, but I think it's be careful about that today. I think it's much more focused to take that you have this process called proof of value. We deploy and then we service our models. But the actual, there's no real focus and deployment for a data scientist. I don't need to. That's an IT. When I say deploy, it's more of an IT thing. What do you think? Productionize the model. What we want as data scientists to really focus on the greens. So before I even start a project, I want to ask, what is the total opportunity? So that I know that I'm going to go into something with the most value. And for predictive maintenance, it's not just okay, I know predictive maintenance has value versus all the other things we do in supply chain and HR. And okay, predictive maintenance gets a little piece of the data scientist attention, because we have 23 data scientists to serve all the needs of the whole company. And we have about a team of 5 to 10 on predictive maintenance. A pretty big. But then you have 10, 20, hundreds of functions and points of interest in these machines. So how do you know what to go for? And initially, it was when as a technology project years ago, as you saw, it was it was kind of we needed to start to develop the idea of the sensors and the IT and the connection. So people started just to propose, it probably is cool to do it here and there. It was more of a technology geek out. But when we really started to get into now we need the model, we need to look at where is the most value. So we have something called the total opportunity. And I've heard it before, don't have your data scientists get into the idea of business cases. This is like a business case, but it's very loose. I mean, for me, total opportunity is just throw out a number of the opportunity. If you're looking at a supply chain, a warehouse is so much stock. We have 10 million euros of stock. Okay, that's an opportunity to reduce it. So you just throw out these, for predictive maintenance, might mean we have 100 customers with this kind of component. They have this kind of downtime. So that whole fleet of customers has this pain, total pain. And we can take a chunk out of that. The rule of thumb is maybe 20% of projects get deployed. So if you think of all the total opportunity you have, 20% of that could become the next thing, empirical value, the actual thing we modeled on that says that this model has the value to produce the outcome that says you're going to save money. So total opportunity goes into the proof of value. Now, a proof of value is a 4 months iteration on some topic. And you can iterate more times, but it's like a clear, like we have a clear, like we're going to look at this kind of function or this point of interest in the machine, and we're going to take about 4 months. We're going to do that in Scrum, maybe 3 or 4 sprints, and then we're going to hopefully come to an outcome. And I tell you, if you do the work up front, understand your total opportunity, everyone's business mindset is there. You get to a point where you can wrap up in 4 months and then move on to the next iteration and then deploy something and service something. We'll go into what deployment and service means. So let's go more into the total opportunity. You have this idea of the priority and what is actionable and what is big value, and I think this is something we've all seen before. But that's so key that we understand that if things low value but actionable, it becomes a distraction or irrelevant. And I tell you, data scientists will work on irrelevant things, because if there's data, a lot of data, they're going to start looking at, I'll put that through a big data model and I'll just play it with my TensorFlow. They will do that, and you will go sprints after sprints where you don't know what's really happening, but someone's going to continue to crunch data. We have the we want to also really focus on that. You're not trying to look for highly complex problems. We're starting out with just initially, let's understand the KPIs. Let's do something to a threshold. Let's look at signals. We don't need to have data scientists can get involved in modeling, and even if it's simple, as long as it becomes something that is actionable, where we can give prescription to, and that we can, start to service and look at the continuous improvement of that. Because eventually it will become a big deep learning model. It might take 3 to 5 years, but eventually that data science department has built the culture of understanding that whole modeling and data. So eventually we'll get there. The next topic is what we need to succeed. So this is more like, how do you succeed in these proof of values? Obviously, you need your data acquisition strategy, your quality and governance and access tools. That's obvious. I can say I joined Tetra Pak because they said we're all in on cloud. We use the Azure cloud, and that was just whatever. Cloud sounded cool, and I had an instinct that something like, no longer would I be restricted to say, that database is running in production. You can't access the data. You have to do an IT ticket, and it will take 10 years to get the data out for you. That's no longer an issue in the cloud. We don't have those constraints, and we can play around a lot. That's been great. So I strongly suggest, if you have the opportunity to choose the cloud, to go for it. It's great for data scientists as well as business. This idea that we need prescription, that prescriptive analytics. Now, for me, we've seen these charts for many years. I thought that meant that, that this service optimization is something like, yes, in the North Star is like that we have some, all these predictions and then probabilities of failures and likelihood that we have to do something, and then all that goes into some fancy optimization model and it tells you exactly when you should do your service. No, actually, when prescription to me was just, we have this function, it's going to run to a threshold, and then what do you do about it when it runs to a threshold? It could just be, we're going to change the maintenance action. The CMS system now says, defer the action. It's just, it does something, and it says, check this part or check that part. There's nothing for the data scientists to do, but it is key that you work together with subject matter experts to know what to do when you reach that threshold, because it's not the data scientists who can decide that. And that, to me, is prescription. Even though prescription from a data science point of view might be something more like a fancy optimization model. So, we've talked about it before, you don't just put data scientists in these proof of values, you have to have people in the business, and you have to have the data engineers on board. Don't let data scientists do data engineering work. It's a blurry line, but it really is. If you want to get the most out of data scientists, do not have them just pipe data or change the JSON format to a CSV. We really have these problems. People are like, it's no big deal, just put the JSON in your Python and great. Well, I don't have time to process that data and risk the failure points. I just want the data to be nice. And I'm not saying perfect, but just formatting and getting it to the right place in the data lake where I can quickly access it in my virtual machine that can process a lot of data. And then you move on to deployment, and now you need more of a DevOps. Do not underestimate the need for DevOps people. We just invested in some DevOps initiatives so that we could start doing containerization and make it easy for people, for data scientists to just deploy. It should be easy, and if it gets complicated, it's something that the data scientists don't have to necessarily, they can basically step away and you move on to service. But this isn't like you start a model, proof of value, and then you get to the empirical value. You say, there's something in this model. Now you determine IT has to do something. Okay, that might take 6 months, that might take a year, but doesn't mean that we can't just have like some kind of development running environment, make it simple to just start getting a weekly or monthly iteration with the business and to see, take a data scientist maybe 20% of the time into what we call the service, where the real focus and target of the data scientist is to provide the continuous value. So if you're saying, I can't provide value because I'm waiting for IT to deploy the model, that may not be the case. You might have you might continue to pilot and prove that the model continues to deliver the value. So eventually it's going to get into the deployment, and a lot of data is going to come, and you prepare and you play around and you set up those confusion matrix and understandings of how your model performs. This idea of thick data and failure data is another key thing to succeed. We have this, like, thick data to me is a concept that means that you have, you might have a few data points, there's a lot of context in that data point. So it's so important to have the subject matter experts involved in that, so that eventually you continue working with thick data and eventually it becomes big data, and you can leverage and do the deep learning and fancy stuff, but it can take many long time to get there. But you need to be able to work and have data scientists work together with the subject matter experts to get the most out of the data. And I don't believe in the idea of saying we don't have the data. For this example, we didn't have the data for breakdowns. People were skeptical. We don't collect every breakdown. We have hundreds of machines and hundreds of customers, thousands of machines. We don't collect on every site. If sites collect corrective actions that we thought were breakdowns, or maybe it's there, maybe it's not. But we did learn that we have many systems that collect. We have a warranty management system. We have a work order system. We have hundreds of sites. So what we set up is this idea that what we called the maintenance visibility project. It became the foundation of we can't go do more if we don't understand what fails. I mean, people are like, well, nothing's happening in the model. Well, because the thing's not supposed to fail every year. So we try to really set up and look at where we can get this thick data set, which may not be perfect, but it starts to start a conversation about like how many things may have failed, how much breakdown were there. We were matching the production. We get a lot of production data. It was just like the machine's on, the machine's off, machine's on, machine's off, machine's cleaning. So we do get a sense of like customers that have downtime. So we marked the downtime. We said there were some events happening. So we started to get a feeling for how long downtimes. We then realized there was some evidence of someone saying it was 3 hours downtime, it was 10 hours. So even though people said there's no great data set, it actually ended up that if we put these sets together, we can get this like visibility into our maintenance histories across the globe, and now we can say, prioritize our work so that we go into those proof of values with confidence. So when we do all that, when we get through, we get a good topic, we work 3 to 4 months, 3 or 4 sprints, and we get to a point where like this model must provide some empirical value, or we stop it. Without that, you could go on for years, just saying like, well, we're not getting the results we want. So keep going, and keep going. But if you haven't done this work up front, the total opportunity, understanding how often this thing fails. We chose this thing with the most failures or the most value. It doesn't have to be the most failures, but if it failed, it's a huge downtime. I came from an energy industry where downtime is huge. I mean, you knew that if the wind wasn't blowing, you'd lose all this revenue. It's huge amounts of money. Most of the use cases are coming from oil and gas. They're like, $100,000 per hour of downtime. Know your downtime. And what we learned is that our customers can range from like $200 to $10,000 per hour. So the context of picking apart isn't just knowing how often it failed. It's like, how often did it fail at which customers? And then we found like evidence that this part has a problem. That this customer is producing like crazy amounts of product, and that now targeting that customer is worth the effort, even though it's like 10% of all customers. It is worth it. So that's how we think, and we then can deliver the value. And value is really exciting when it is significant, because if it's not significant, then you can get to this, say, empirical value. I got this little model, and then nobody wants to actionate it because it's not enough value. So, for example, what is an empirical business case? This is an example. You might, you're looking at some alarms. You went up front. You looked at your target detection windows. You have a no time to react windows. These are all things that you need to do up front. Input. Then you start getting some alerts and collecting information. You need to do this confusion matrix. And I can tell you, it's not easy. It's not something you think about. We think about, oh, we need to get the deployment, we need to crunch the sensors, and I'm telling you, and then you get it out to some people monitoring this, and then, it takes a few months or year to get enough data points and understanding of what a true negative is, a true positive. It takes time. And it's also important that, if you're dealing with sensors, you might analysts might look and say, oh, well, the model said something's broken. No, the sensor might have lost the connection. It might have gotten a little loose. So now they're measuring sensors that are dying. And that's important. We need to know that. But customer-facing value is like, what has he paid for? He's paying for the motor that we need to predict. So it can take a lot of time, and it's really something back to this the service that we say. The service is this continuous improvement. Proof of value is like 3 to 4 data scientists, but when we move into the servicing mindset, we might take 1 day a week of a data scientist to continue to help that department out, but it doesn't become a whole project that requires to do this servicing. We get to the, can we fix that? Sorry. So this confusion matrix is key. And it might be scary. You might have a model that's not working, and you might be a little ashamed to that it's not performing as well. But if you get to this, you might actually figure out that in the context of certain customers, the false positive is not that big a cost. So it's these formulas that really, it's not just how many false positives, false negatives, true positives you have. It's the formulation of it, the empirical business case that says the true positive is worth that we saved on average this much downtimes. We have to incorporate a risk of the false negative. That is going to be the downtime, but then we end up that even a precision of 70-60% is still worth money, and we can continue improving on that. So here's an illustration of that. A part we had, it starts out, it took a few months. You get this one part had 6 true positives and 1 false negative. And it had 0 true false positives. It is what it is. And that can be continuously monitored for some value. We determined the downtime of that part was worth $17,000 on average for the particular representative customer. And we see that there's value, because if they didn't have it, they would have lost that money. Now, it can be different when you start false positives, and you can get cases where it can be very expensive, or the perception is that, no, stop telling me to check my machine, and that could be something you should take into account. I also take into account that empirical people might say, oh, well, there's not much value here. You only detected 6 things. Well, but if we scaled it up to the whole fleet, if theoretically the whole entire population of this particular part was, you'd be detecting hundreds of things. So it's also that perspective of us being like we're like a vendor for this. We want to see that all customers are eventually going to onboard the solution. So there is an inherent scaled up value there. So finally, we're going to talk about how to sustain the value. So we're at this continuous value. And this is a quick wrap up of a lot of the things I've been talking about. There is just, in the proof of value phase, you're going to have this excitement about the algorithm. You might have overhit, you might end up having overfitted it. There's a lot of pressure to perform and get something out there. So you might have had this perception. But as you go into service, and data scientists are not fully attentive on that, they need to move on to something else. Things happen, and if you don't watch it, it's just going to go. It could go down like that. So you need to have this continuous mindset that someone who understands the model is continually monitoring that. And it doesn't have to be a full-time job. It can just be, like I said, 1 day a week, not even, depending on the complexity. But it's important that those people in business unit that get these models, they feel like, you need to kind of feel like you care. Hold their hand, meet them regularly. I go once a week to our performance management center, and we have a conversation. The couple of weeks ago, after a few months of running, we were at the point where we could do this. We had enough. There's a particular example that we had this confusion matrix, and we were able to put the model and precision and recall into a real visualization of what it is we're doing. How are we doing? We're not doing too bad on this. And there is positive value here for the average customer we have. You'll notice one thing is that the true negative missing. And this is another, you could call it the confusion matrix. It is confusing. It took me, even as a data scientist, some while to actually working with real numbers and asking what is it we're really considering. There's this thing called accuracy. It does include the true negative, but it's a completely arbitrary number. And if I would, for sensor data, which is daily, each day something doesn't happen, or yes, it does happen. It's rare to have something happen. So what is a true negative? Is every day I don't detect something, I get a true negative? Well, that could be thousands of days. So your model may end up having, 99.9% accuracy. But that's completely arbitrary. The real metrics are precision or recall, where precision is basically the opposite of that 77%. Say we have 23% false positive rate. That means 1 out of 4 times we're wrong. We send guy to the machine and it's not broken. But most of the sites, we have someone on site, so they just go by and they check and say it's not broken. Not that big a cost versus what it could, the 3 out of 4 times we do detect and avoid many hours downtime. So that's okay. And recall, it's been getting better. I mean, in the beginning, we were getting some calls saying you missed a prediction, and then eventually you're like, 9 out of 10 predictions are good. So these metrics, precision and recall, do not require a measurement of true negatives. And for this kind of predictive maintenance context with sensors, it's not Google and Facebook just measuring millions of people if they like something or not. This is key. Do not allow anyone ever to use true negatives in any a priori model empirical value discussion. It completely is distorted. So recommend strongly to use these guys. So finally, sustaining the value is this. Fundamentally, it's like about this reinforcement learning. Now, that's not a technical modeling. The idea is that we continuously monitor our models. We're engaging with the business. We're taking ownership of our models, but not, the thing is the racing model. We take responsibility for models, but the business takes the actionability of it. And it's this reinforcement idea. It's the human. It's the human in the loop, and it continues to be. I don't see anything really being fully automated in this for many years. And data science is this team sport. So we will get to improve decisions with this mentality. That's it for me. So we do.
Okay. Thank you very much, Noam. Thank you.